Hello. So today we are learning modulo arithmetic. So let's see what is modulo arithmetic. So when we divide two numbers, let's say we divide A by B, we have an equation like something Q and a remainder R. Okay. Let's say we are dividing A by B and we get quotient Q and something gets here and we get the remainder R. So what is modulo? Modulo gives the remainder when we divide two numbers. So what is A modulo B? A modulo B is R. We can also represent this by Euclid's division lemma. So you might remember Euclid's division lemma, that is A equals BQ plus R. Same thing goes for here. We are dividing A by B and getting a quotient of Q and a remainder of small r. So we can write this and this. In if we want to get remainder, we'll apply modulo arithmetic. Okay, so now let's calculate these four questions. So we have to evaluate 22 mod 4, 35 mod 7, minus 15 mod 2, and 4 mod 9. Right. So let's calculate 22 mod 4. So what we have to do, we have to divide 22 by 4. 4 5s are 20 and we get 2. So what is the remainder? 2. So 22 mod 4 is 2. Nice. Next we have 35 mod 7. So you know that 7 completely divides 35. So remainder will be 0. So 35 mod 7 is 0. Next we have minus 15 mod 2. Now this one will do. See, 2 divided by minus 15. Okay. So what we'll do? We'll go 2 sevens are 14. But no. See, whenever we use modular arithmetic, the remainder cannot be a negative number. So if we go like this, 2 sevens are 14 and we subtract it, what we get 29 and minus. So we cannot do that. We don't want remainder to be a negative integer. So what we'll do in this case, instead of going sevens are minus 14, we'll go a number which is bigger than 15. So let's go like this. 2 8s are, we know that it is 16. Now, due to we have to what we have to do, we have to change the sign here. So we'll take minus so that we get minus 16, and when we change the sign, we get plus 16. So now it gives us remainder of 1. So what is minus 15 mod 2? It is 1. In this case, we were getting 29, or if we go 8s, we'll get minus 16 and get minus 31, but both of these answers will be wrong because we don't want remainder to be a negative integer. Last we have 4 mod 9. So 4 mod 9 will do the same thing. 9, well, you can remember like this. If the number that we are going to find out modulo with is greater than the dividend. Okay, so then the answer is 4. How? See, when we're dividing 9 by 4. So obviously if we go 1, we'll get a number greater than 4. So what we'll do, we'll go with 0. And what is the remainder? Remainder is 4. So this was, so if the first number is smaller, that is the dividend is smaller than the divisor. Then what is the value of the modulus? The value of modulus is divisor. Okay, let's now see what is congruence modulo. So we'll see this with three examples: 15 mod 4, 23 mod 4, and 33 mod 6. Let's calculate them all. So 15 mod 4, 15, 4 threes are, and we get 3. So 15 mod 4 is 3. Next we have 23 mod 4. Let's calculate this too. So 4 fives are 23. So 23 mod 4 is 3. Next we have 33 mod 6. So 33 mod 6 is also 3. So in all the cases, we have the same result of modulo. 15 mod 4 is 3, 23 mod 4 is 3, and 33 mod 6 is 3. But we'll say that 15 mod 4 is congruent to 23 mod 4, but we cannot say that 23 mod 4 or 15 mod 4 is congruent to 33 mod 6. Why? Because in congruence modulo, the remainder or the value of the modulus mod should be same, equal, must be equal, and the the divisor should be same. Dividend must be can be different, like 15 and 23 are different, but divisor, this 4, this must be same, which is not in the case of 6. So we'll say 15 mod 4 is congruent to 23 mod 4. So that's how we write the congruence modulo. Okay, so now let's see how we can apply this congruence modulo to find out the answer of this question. So what it says, find the remainder when 481 plus 392 plus 604 plus 937 is divided by 8. Okay, so see, we have to determine the remainder when this are divided by 8. When the sum of this number is divided by 8. So what we can do first is, let's take 481 mod 8. So what we get something mod 8. What mod 8? We can calculate it here. So let's divide 8 by 481. So 8 6 are 48 and 8 0 are 0. So we get 1. So this must be congruent to 1 modulo 8, right? Because if you divide 8 by 1, you'll again get 1. And if you divide 481 by 8, you get remainder of 1. Next, we can do the same thing for 392 mod 8. Now this will be some number and mod 8. So 392 mod 8, 8 fives, 8 fours are 32, 72, 8 nines are 72. So we get 0. Next we have 604. So what is 604 mod 8? 8 sevens are 56, 44, 8 fives are 40, we get 4. Next we have 937 mod 8. So we get one remainder, right? So what we can do, what you have to do? 481 plus 392. So what you should do, you should add all these equations to get 481 plus 392 plus 6, because we are adding all of these. So what we will get? We will get 481 plus 392 plus 604 plus 937 modulo 8. Now this must be congruent to what? 1 plus 0 plus 4. We have to add it here 2. 1, 4, 1, 5, 1, 6 mod 8. So we can say that when you divide this by 8, you get a remainder of 6. Now you can check this also. So let's say we have to check this. So 481 plus 392 plus 604 plus 937. What is this? 2414. And when we divide 2414 by 8 to get the remainder, we get 6. Okay. So let's see our next question now. So here we have the same type of question. Instead of just adding, here we have to multiply. So the process will be same. First we'll get 512 mod 6. Next we'll get 319 mod 6. So let's see. Okay, 6 6 8s are 48. 5s are, so we get 2, and 319, so we get 1. Now we have to multiply these equations. Multiply equation 1 by 2 to get 512 multiplied by 319 mod 6 will be equal to 2 multiplied by 1 is 2 mod 6. If you multiply these two numbers and find the modulo with 6, you get remainder of 2. Let's quickly check this. 512 multiplied by 319, 16328, and modulo 6. So you get the remainder 2. Okay, let's go on to next question. So next is also a similar one. So I will give you as homework, right? You can do the same thing. 512 mod 5. Actually, it's a lot easy because you have number 5. So you know 5 divisibility of 5 is at the last place of any digit. If you have 0 or you have 5, then only the number is divisible by 5. And if you have any other number, then it will be not. So if you see 512, 512, if we round off this number to the nearest tenth, we'll get 510. So 510 will be exactly divisible by 5. So what we'll get when we divide 512 by 5, we'll get 2. So this is equals to 2. You multiply all these, okay, and take a mod, you will get 0. Okay, let's see if we can quickly calculate this. So this is pretty big number, and you can see the last digit is 0. So when you'll divide it, uh, take the modulo by 5, we'll get 0. This was all we had for today. If you have any other question, feel free to let me know in the comments, and I'll definitely answer those questions in the comment box.